Okay, in problem 2, we have a can of bolts and nuts being pushed along an x-axis by a broom along the greasy, frictionless floor of a car repair shop in a version of shuffleboard. Now, I don't know why any self-respecting car mechanic would leave his floor greasy, because that's a safety hazard, but anyway. So we get the work here done as a function of the can's position, so work versus position. Okay, so we want to find first what's the magnitude of the force. Well, work is, properly speaking, work is the integral of force dotted with ds. Okay, what that amounts to is that if you want the rate at which work is being done per distance traveled, that's actually a force. It's a little, actually, strictly speaking, it should be dWds. So let me do that, and maybe that'll explain things a little better. But dWds, where s is your distance traveled, the amount of work you do per distance traveled is the force. Really, it's sort of dotted with the direction you're going, but it's the component of the direction, the force in the direction you're going. Okay. The point is that what we can do here very easily is the slope. The work done is simply the slope of this work versus x line. I'm sorry, the force is simply the slope of the force. People are sending stupid emails out, and I'm getting distracted when the little ding dong happens, because it's some stupid like FCPS, here all teachers have to take a survey on blah blah blah, and it's stupid stuff like do your students have materials available to them to help them learn when you're not around, and all that crap. Anyway, and not that it's a bad thing to ask, but it's freaking annoying having to answer a survey. Yes, I make sure my students know what to read in the book if I'm not around, blah, blah, blah. Anyway, so the slope of this line here is going to be the force, the magnitude of the force. So very simply, we go up, 6 joules in 2 meters. So the slope of that is simply 3 joules per meter. Right, which is, and it's joule per meter, since a joule is in Newton meter. So we could, rise over run is, now I'm on the eraser still. Wait a minute, there we go. Rise over run it's 6 joules over 2 meters, which is 3 joules per meter, which is 3, and a joule is a Newton meter per meter. So the slope of that is 3 newtons. Okay, so there we go. So the answer should be 3. I'm just going to check that and make sure I'm not doing something incredibly stupid. Okay, great. And then if the can had an initial kinetic energy of 3.40 joules, moving in the positive direction, the x-axis, what is its kinetic energy at the end of the 2-meter displacement? Well, again, this is pretty easy. This is a one-body system, so change in kinetic energy is the work done. And the work done in that whole thing, remember at the end of the plot, was 6 joules. So if the initial kinetic energy was what was it say, 3.4 joules. This is just final kinetic energy minus initial, so minus 3.4 joules equals 6 joules, and then so final kinetic energy is 9.4 joules. So let's see, and 9.4 joules. Okay, there we go. So that's problem 2.